Bruh. Hello everyone, and welcome to Monday's stream. Oh. Hopefully everyone had a really nice weekend. The weekend situation here in the UK has been quite interesting with the whole Jubilee thing. So it was a long weekend for us, and it was also really enjoyable. It didn't rain that much. Hypervoid. I managed to catch show at the theater on Saturday. Was really good. It's one of the reasons why I actually love living in London, and uh, even though the rest of UK is, well, yeah, totally normal island, but yeah, the London is still very much the reason why I still live here. I would be very hard pressed to find a better place for me and my partner to live. So it was good. It was a good weekend. I also managed to do the prep work for today's stream, so it's not completely flying by the seats of my pants here. So we're gonna get something done, and hopefully will be a good addition to the GObject deep dive series. And yeah, after that I will probably take a little bit of a break and try to edit the 3 episodes, the 3 streams that I've done on this topic, and try to put an edited and condensed version of the streams on my YouTube channel. But it will, I mean, I'm not great at editing videos, and editing streams is kind of an art at this point. Hopefully I'll get to something decent, and then it will be useful to somebody else that couldn't catch the streams live, or that do not have time to watch 3 hours and a half ish streams. Even at twice the speed, they are pretty long. I know they are because I have to go through them in order to mark the various sections for the YouTube upload. So I have to watch them at twice the speed and mark down the time every time the topic changes. Oh, it's always good fun. Well, I say good fun. It's not super fun to listen to my voice constantly. I do not enjoy that. I managed to come to terms with it because I've done a few talks over the past, I don't know, 10-15 years, and the overall thing when you start doing talks is that you have to listen to yourself giving the talk, and you have to do trial runs and check that you're actually talking correctly and staying within the time constraint. And that gets, well, interesting after a while. Anyway, yeah, I don't know anybody who actually enjoys their voice, the recorded voice. Hi, Georges. Oh, I saw that you just announced the stream for tomorrow. It's gonna be fun. So tomorrow, Georges is gonna do a stream on Gumshell on his YouTube channel. So make sure um, to join him in the development of Gumshell. And if you're watching this on the VOD, then you should go on George's channel and watch the VOD for his own stream. Hi, Six Pounder. Back to streaming. Well, I mean, it's it's time consuming, so I understand completely the people that do not do this with a very like regular cadence, uh, because it's hard. Thanks for the adread chat. It was still not sponsored. Yeah, no, I want that sweet Google ad money. So uh good. Oh, oh, I'm getting my tea. The temperature in London collapsed after like 2 weeks ago when it was really warm. Like, well, not really warm. It was warm for late spring, nearly summer, but then the temperature just collapsed, and now I'm basically just shivering. So I'm drinking very warm tea after spending a week with cold brew coffee and ice. Hi, Gunibert. So I'm more in the early spring now setting. Ooh. Okay. So today's stream is gonna be in two parts. So the first part is gonna close the overview on the types provided by GObject. So we're gonna talk about interfaces mostly. Um, I'm I briefly considered doing a little bit of an overview on the enumeration types and box types, but I think those merit their own stream at this point. They are useful types, but they are also a lot simpler to deal with, so there's not much to say about them. The box types and the G-type interface types, I'll probably do another stream on specifically on those, because people have been asking on Matrix, RC, and in other places when to use G-type instance and GObject, and when to use box types. And for that, I wrote an entire blog post about that a couple of years ago, but also I think they warrant their own kind of deep dive and like description, because it's a little bit more complicated. Sorry, it's not complicated in terms of theory. It's more a set of best practices, more an art, basically just experience. At some point you'll get the experience to do this, instead of being something that is encoded in the API. So I'll probably do a deep dive on that, either late this week or next week at this point, but we'll see what happens. And yeah, so for today, we're going to talk about interfaces, because interfaces are kind of funny in a couple of ways. And the second part of the stream is going to be about how to implement the model view controller design pattern in GObject for your applications. And it's going to be a simple example, but it's probably going to be useful as a base to understand some of the best practices of like GTK and GObject API that are used in modern GTK applications. A bunch of people will already know how to do this, so it's probably going to be just rehashing of well-known features and well-known like techniques. And if you've seen the Amberol videos, for the streams that I make on when hacking on Amberol, I mentioned this pattern and the implementation of this pattern in Rust multiple times. But today we're going to do it in C so that people understand how the API interacts with all the APIs interact with each other, and also it's probably going to be easy to port to other languages if we start with C. And by port, I mean adapt to other languages, not like the mechanical port of this code from C to, I don't know, Python or JavaScript. But yeah, we'll see where it goes. I'm still gonna play it by ear, but I'm going to try and reuse some of the stuff that I've been preparing for the stream. So when we are talking about interfaces in GObject, we are typically talking about something that sits between the pure interface of interface type of Java and the less pure mixin type of C++, because that's basically where GObject sits, is an intersection between C++, a type system that is C++ oriented, and the theory of a type system that is mutated by the Java type system. It's a reflection of the time. The GObject type system was written when Java was dominant, was the object-oriented language by definition. And it mutated a lot of the design ideas from Java. So we are going to switch to my desktop, and I still have open Builder on the background, but I'm not using Builder now because I don't need the entirety of Builder to just describe this. So we've seen GObject being a very classic of type system with simple inheritance between a parent type and a derived type. It's single inheritance, so a type can only have one parent type. This is because of how type inheritance is implemented in C. You cannot have at the beginning of the type multiple structures there. So if you are writing your example object, you have to inherit from GObject. You cannot inherit from GObject and my awesome object as well, because as we've seen, the entire point of this is that this first field will expand to the contents of GObject, and so we'll expand to the contents of each ancestor of the GObject type. So having another type here doesn't make any difference at all, because we are always going to start from this part, and the memory layout will always start from this field here, this member of the struct. So we cannot have two parent instances, two parent types. So how do we solve this? How do we solve the fact that not everything can implement multiple protocols, can implement multiple ancestor types? So an example object might also be serializable, and another can be bound to an action, for instance, or can be, I don't know, deserializable as well as serializable, can be whatever, can be other types. One option is to have a very complicated like ancestry. So you inherit from GObject, and you inherit from a serializable type, and then you inherit from a deserializable type, and so on and so forth. But the problem is, of course, is that you have to know all the ancestors beforehand, which means that every ancestor also has to know every ancestor on that it will inherit. So you will have a very complicated inheritance chain replicated multiple times, unless you are adhering strictly to a specific set of ancestors. So every deserializable type has to inherit from a serializable type, which has to inherit from GObject, for instance, which means that all your types will have to be both serializable and deserializable, for instance, which is not great, because then you cannot make a purely serializable and a purely deserializable type, for instance. So the way that this is usually solved is not with an is a type of hierarchy, type hierarchy. So example object is a GObject, just like GTK button is a GTK widget, which is a GObject, and so on and so forth. The other way to do this, instead of using an is a inheritance, is to use an interface inheritance. So in an as a or a does, like relationship. So a GTK widget is a GObject, but also GTK widget does or interprets the role of a GTK buildable type. So this is the theory behind the interface like implementation. So what is an interface at this point, especially for GObject? An interface is a non-instantiable type. You cannot instantiate an interface, and it is a type that cannot be inherited from. So you cannot create an interface that has an interface as a parent. So it's a flat hierarchy that is applied to your object. In GObject, this is kind of pretty simple at this point. So you start from the interface definition, which is the usual example. Let's continue with the serializable. You start with the type def. You create your struct. And then the first member of the structure is going to be the gtype interface. So every single interface in GObject has to inherit from the G-type interface type, which is just a opaque type that contains a type definition. Nothing more complicated than that. This does not change the example object at all, because interfaces in GObject are not composed at compile time like the inheritance chain is. So a compile time example object has to contain GObject, and compile time GTK button has to contain GTK widget, which has to contain GTK GObject. Interfaces are composed at runtime. They're composed whenever you instantiate a type. So whenever you create an instance of example object, the interface will be instantiated, well, will be attached to the type. The way it works is less about the type instance and more about the type class at that point, but it's similar in the structure. You allocate enough to ensure that the GObject class also contains all the interfaces that are there. Playing games with the allocation is how most of GObject is implemented. You implement that, you implement the private data type for the instance and the class. We do a lot of games with the allocation. Whenever we turn to you a pointer to an instance or to a class, that pointer is defined to be the structure, a pointer to the structure that you also defined in your source file, but it is very far from being the actual memory that has been allocated to you. There's a lot of games going on in the background, which is also why you cannot do things like pre-allocating like 100 instances, or you cannot do things like reallocating a GObject, or do other like weird memory management things that you could do with, I don't know, an array of a C array of any type, because the memory that is given to you is not the actual memory that has been allocated. So it's this is more C esoterica than useful for people that are actually using this API or this library. It's interesting if you're trying to hack on this library. So if you're interested in doing things like how's it called? Yeah, like contributing to GObject or implementing new features, or do some performance optimization or things like that, then learning how the memory management is done is very interesting. If you're just consuming the API, if you're just implementing your own thing, then it's probably best not to look too much behind the curtain. It's an interesting topic, but probably not for everyone. But yeah, so what does an interface contain? Interfaces typically contain whatever a class structure would contain. So virtual functions most of the time. So it could be like, let's say this. So this is a serializable interface. Let's add a very simple couple of methods here, like can serialize and serialize. This was very stupid. Sorry. Yeah. So I had to fix this because I'm a little bit dumb. You need two types here, and this is again C esoterica. So the first type here, example serializable, is the type of the instance, is the type that you will be used to pass around as a pointer to your instance here. The other type def that you're creating, the other struct you're creating, is the interface, and the interface is the actual thing that contains virtual functions and interface data, specific interface data. The interesting part is that this type def here is completely opaque. There is no struct example serializable anywhere. There is no struct example serializable anywhere, because you're not going to use this. You're not going to use this structure as an actual structure, as like a blob of memory that is going to be placed somewhere. It's always going to be used as a pointer, and in C, a pointer to something is a pointer to anything, because you can cast it away, right? So if you do example object here, and you want to use it as a serializable instance, you can do example serializable. Here. And that's it. You will never access the contents of example serializable. So all you need is an opaque type, and an opaque type doesn't need an actual definition. It only needs a declaration of a type. So how do we, I mean, this is clearly, in this case, we are using the casting macro, which is not a macro anymore. It's a static inline function. But we're using this like checked cast. It's not a simple C cast, even though it collapses to 1. But we are doing this at runtime because, as I said, interfaces are composed at runtime. They're not composed at compile time. So in order to make these equivalents actually true, in order to ensure that you can get the serializable instance from your own object instance, you have to do one thing and one thing only, which is bind the fact that example object here is going to implement the example serializable interface here. And the way you do it is, I'm going to use the macro here because it's easier to see like immediately. Is going to be gdefine, in this case we're defining a type, example object. It's going to inherit from gtype object. But instead of so this is the typical way to define a type in your source code. Instead of using, well, yeah, this one will define your get type function, the class in it and instance in it will be pre-declared for you, so you can do whatever you want. So how do we add the fact that this type also implements the serializable interface? Well, instead of using gDefine type, I have to use gDefine type with code. And the last field of the gDefine type with code macro is, well, allows you to add a custom code to your type definition. So it will expand to get type function that allows you to call additional function inside it. And you use the GImplement interface here. You specify the type of the interface. So example type serializable. And then you specify a function to be called to initialize the serializable interface. So example serializable. So this macro here expands to a bunch of C gobbledygook. Let me get you. There we go. So this macro here will expand to a function call that will basically say, okay, when you are defining this new type, ensure that this type is bound to the interface type that you're passing here as an argument. And whenever you're instantiating the type, I don't want to say something wrong, so I'd have to double check the code, but I think it's done before the class in it is called. Also call the interface init function that you're passing here. So the entire thing is mostly a way to say to the type system, hey, this type has an additional type information that is an interface. It's what we call interface. So whenever you're allocating the class, you also allocate enough to fit the example serialized interface in this case. And then whenever you're instantiating or initializing the type, then you should also call this extra function to initialize the interface virtual function, the interface vtable. And inside the example serializable default init, here you're getting the interface vtable here that you define in your header file or whatever. And you can initialize the virtual functions here, the function pointers that you get here with your own implementation. So for instance, in this case, might be can serialize, it's going to be example object serializable and serialize, and interface serialize equals example object serializable serialize. And then every time these virtual functions get invoked, then they will get passed an example serializable instance here, which is really an example object. So you can directly cast the serializable away to an example object because the pointer points to an instance of that type, and that type implements the interface. Okay, So the other important part of, well, the other role of the default init here, the instance initial, sorry, the interface initialization function, is that you can use it to do things like install properties and install signals, because G-type interfaces can also have signals and can also have properties, but they are kind of, well, not signals. Signals are perfectly fine. They are stored somewhere else inside their own thing, and it's just a function call, so it doesn't matter. But properties are a little bit more complicated because interfaces have no instance structure, so they cannot have state. They cannot hold any data. The serializable interface structure here is exactly the same as a class structure. It's shared across all instances of a specific type that implements the interface. So how can an interface, which is an abstract type that has no structure, no instance structure, that can have properties if it cannot hold any state? Well, your object can hold state, your type can hold state, because your type has an actual instance. So whenever you're registering a property on your interface, you're actually making a promise. You're saying this interface has this property, and this property is going to be defined by the same type of gparam spec, like the structure that any GObject property has, and so on and so forth. The main difference is that then when you're creating your own type, when you're creating your own object that implements that interface, you will have to tell the object type, hey, I have a bunch of properties from this interface here. Please map them to properties that I'm actually handling myself on my own. So to make an example, because this is kind of what the hell is Emanuele saying? It's kind of a little bit weird, but so we have to use, let me see first. Instead of using GObject class, we use GObject interface install property here. Face, and then it's going to be pspec. It's going to be G, for instance, param spec string greeting null hello world param retry. Okay. So we are actually here creating our own property, like the greeting property, and installing it on the interface. And it's fine, right? It's pretty much like you would do it in GObject. So in GObject, it would be GObject class install property. And it's going to be like class, and then prop greeting, and then gparam spec string greeting, and blah blah blah. So you can already see there is a difference there. When we're installing the property on the class, we are actually binding the gparam spec here to identifier here that we are going to use inside the set and get property functions in order to get and set the property. When we are doing it on the interface, we are not passing an identifier at all. The param spec string exists unbound from an identifier, which means that we cannot use it for setting and getting anything. There it is. So we're just making a promise and saying this interface, the example serializable interface, as we promise you that it has a property, and that property is going to be a string property with the name greeting and default value hello world, and it's going to be readable and writable. So whenever you go into example object class init, at that point, when you're initializing your class, you will have to say, okay, I implement this interface, so I take care of the interface variables. I take care of the interface properties. So, right. And you do this by using the GObject class override property. So you do this, and then you do class, and then you do proc greeting, and then greeting. So you're telling the GObject type system that this class is taking over the greeting property that is installed on any ancestor or any interface that has been that is part of this this type, and it's going to take care of it inside the set and get property virtual function using this particular ID. So I'm going to venture into something that is probably going to be a little bit controversial here. I'm gonna hazard the probably the only controversial bit of this deep dive and say, if you have an interface, don't ever add a property to it. Only use virtual function. Don't install properties on interfaces, and don't override them inside your class in it. Because yeah, so this is kind of, it's not even a best practice at this point. I'm basically, yeah, it's useful to have properties on interfaces because they expand your API capabilities. You can do a lot more than just calling virtual functions. You can use them to bind things and just inspect your API at runtime and do transformations and so on and so forth. And they're useful, yes. There is a problem that is the forward compatibility for your API. So, as I said before, interfaces are composed at runtime, not at compile time. This means that unlike the class structure for a type, where you have to have class, you have to have padding here. So, you have to have padding here if you want to expand the functionality of your class. So if you want to add a new virtual function at some point, you have to do something like this. You have to add a function pointer and subtract a pointer from here in order to maintain your ABI compatibility in the future with existing code. Unlike that, you can add anything to an interface. You can add more virtual functions, you can add fields there, you can add whatever you like. You cannot remove anything and you cannot reorder anything, but you can add new stuff. And that will not break the ABI of your library or your code. So it's perfectly fine to do that. And it's a very powerful mechanism that you have at your disposal to improve your, I don't know, your library code or your API. Because, again, it makes it more flexible, more extensible, and it doesn't break anything. Unlike adding stuff to a class structure, where you have a hard limit on the amount of padding that you have at your disposal there. The only problem with properties, though, is that once you make a promise here of having a property, the promise has to be fulfilled. So, another example. Let's say I add a variant serialize harder. So let's assume I add a new virtual function here that in version, I don't know, 2. The version 1 of my interface, it has these two virtual functions, can serialize and serialize, and version 2 has the serialize harder virtual function. Existing code will have the implementation of the can serialize and serialize, but will not have the implementation for serialize harder because existing code was compiled against version 1, whereas serialize harder was implemented in version 2. And that's it. That's fine. So the interface author, which means you, can decide to provide a default implementation of serialize harder, because it can fall back to serialize and not have any error. So it can basically just ignore the past error there, or it the author of this interface can decide to check if the serialize harder virtual function is set or not. Just like class init, everything, and instance init, everything that is allocated by GObject is nullified. So when you get into the default init here, everything you don't explicitly set will either be set to null or to the default value that is being set by the serializable interface initialization. So there can be a default handler here whenever you create your own interface, or that can be null there, and anything that calls serialize harder will have to do a null check on the virtual function. But again, it's perfectly fine. It's perfectly acceptable. Your code does not need to change because somebody has added a new interface field here, except for properties. So if version 1 has of the property of the interface has a greeting property, and version 2 decides to add object interface install property back event counter decides to install a new property, like a new counter property, now all the implementations of the serializable interface will fail. So you wrote your code against version 1 of the example serializable interface with a single property there. You add another property in version 2. You don't compile, you run your code against version 2. And now every single time you try to instantiate example object, which implements the serializable interface, the type instantiation fails. And it fails because properties are a promise. They are not versioned, and they are a promise, which means that every time you add a property, every single implementation of the interface that defines that property has to override that property. It cannot be not overwritten. It cannot be ignored, because the calling code does not know which version of the library is actually being used and which version of the type is actually in use. So my strong suggestion, it's at this point can only be a suggestion, because it's an actual feature and it's useful. I can see the usefulness of this, and it clearly is useful for people. But the fundamental point is that if you're writing a library and you're providing an interface, don't add properties to it, because then all the ability to say, I can expand the interface at a later date with new virtual functions and new signals and new whatever, will absolutely fail, because the properties are not versioned. The properties are part of the ABI. The size of the interface is not part of the ABI. The properties are part of the ABI. So if you add a property, now you have to basically bump up the requirement for every single of your projects for that particular property, for that particular interface. Otherwise, it won't work. Otherwise, it will just not be possible to instantiate your type that implement that interface. So again, the strongest suggestion I can make, and at this point can only be a suggestion, is if you're providing an interface for third-party code, like you're providing a plugin API, or you're writing a library, then don't use properties on interfaces. You're just asking yourself, you're just inviting more work for yourself, more work for the people that are actually using your code, and in general, they're not worth it. So don't do that. It would be nice if that didn't matter. It would be nice if properties did not come with all these strings attached. If the property API were to be a little bit more nice and a little bit more forgiving, but this is the hand that we've been dealt, and we cannot do much about it. So if you're having an interface and you control all the colors and all the people that are going to implement, all the places that are going to implement that particular interface are under your control, then use properties. It's fine. You're going to have to deal with that anyway, so who cares? But if you're creating public types that are going to be used by third parties, then don't do that. It's not a good idea. It rarely works. I think very, very few interfaces in GTK actually use properties at this point. Yeah, properties are a mess. Are one of the messiest bit of GObject. I probably said this already in the previous episode, the previous stream episode, but yeah, properties are kind of a mess. They have limits all over the place, and they are not well integrated. They are slow. They are very painful, and yet they're very useful. They're one of the most useful pieces of the GObject as a class. And in the next part, we're going to see how to use object properties to do like model view controller stuff. So it's going to be, it's hard to tell people not to use properties because they are very useful. They are absolutely a good thing to have. It's just that their current implementation is so pervasive and so broken. They are really hard to replace with something that actually works. I tried to do that like for years, and turns out you have to do a lot of work on everything. Even though object properties are part of the GObject, in order to make them work properly, you really have to touch every single bit of the type system. Right, so yeah, the last bit is going to be how to invoke virtual functions, but because basically, well, it's not very useful to just say, I mean, it's not incredibly useful to explain how to invoke a virtual function. It's not complicated at all, but there are some tricks that are kind of important there. So the first one is, let's drop this here. No, yeah. So whenever you're creating an interface here, you also have to register the type, of course, because the type that we're using here is going to be the type that of the interface has to be part of the type system, so you can actually use it. You can tell the type system, hey, this other type implements this interface. So the way you do it is gdefine interface. Yeah, need to double check again. Sorry, it's not interface type, it's gdefine interface. It's very... So this one should not be called gdefine type, should be gdefine object. The reason why it's called gdefine type is because it actually is not limited to object types. It can be used to with any G-type instance. So you can use it to create your own, whenever you create your own G-type instance, like derived type, so your completely separate type hierarchy, you can also use gdefine type. But then we did a bunch of things there that are not super nice, like define boxed. Yeah, for instance, gdefine boxed is gdefine box type instead of gdefine boxed. Why? Because. So, yeah, GObject, for being a library so fundamental, and for being a library that has so few committers and so few people that actually know how it works, the consistency sometimes leaves something to be desired. So this is going to be serializable, example serializable, and the prerequisite is going to be G-type object. So you define an interface, and as usual, you give the camel case version of the name, which will be used for actually the name and the type. You give the snake case for the prefix of any symbol that this macro will expand to. In this case, example serializable get type. And then you have to provide the prerequisite. So this macro here requires G-type object, but strictly speaking, that is not entirely true. But yeah, every interface can say, I have a prerequisite type, so I have any type that is implementing this interface must be an object type, for instance, or can be I don't know, another kind of type that you want to access here. So you can define a minimum requirement for the type that that is going to implement the interface here. And then just like G-defined type will pre-declare pre-declare the class init function and the instance init function, the G-defined interface macro will define the example serializable default init. So this actually should be called example object, so we don't confuse the two. So this is the function that will be called with your type. Well, will be called for your type here when you are implementing the interface. This function here will be called, will be defined and will be called whenever you are initializing the interface yourself. So this one is the basic. So you can use it to do default can serialize, and is serialize here. It's going to be default serialize. And default can serialize. Reason false. So you can use this default init here to provide the default implementation of your interface virtual functions. So for instance, the default can serialize is going to be return false unconditionally because we don't know how to serialize ourselves. And the default serialize function will return null because we don't know how to serialize ourselves. We are an opaque type here that has no state whatsoever. These are the default implementations here, and I'd contend, well, as a best practice here, you could literally not set these to anything and they would be initialized with null. But then if you do serializable and serialize, then basically you have to check every time that the virtual function has been overridden or not, and if it hasn't been overridden, then you have to return a value yourself. It's not fun. It introduces more complexity into the API and the implementation, and it's not really what I would recommend. So I always recommend to provide a default implementation in your interface definition, because then the actual functions that third-party code will call for you, it's going to be something like this. Sorry, this one is going to be this. Turn self. Sorry, eFace and serialize. So you can count on the fact that this function pointer is not going to be null. It's never going to be null. And there is going to be implementation somewhere, even though the default implementation might be like return false. Otherwise, you have to do if eFace and serialize not equals null. Otherwise, return false. So basically, you have to embed the check yourself into your like wrapper code, which makes it harder to override, which makes it harder to decide to do something else to improve the default implementation, for instance, and so on and so forth. So yeah, the strong suggestion in terms of like literal best practices for modern GObject code is to provide a default implementation. That's it. And as I was saying, providing a default implementation is actually a lot useful when you're expanding the interface in the future. For instance, as I was saying before, let's say we decide to add serialize me hardware. Like an error variant of the serialize function. So you can choose to do something like this. Let's see, can decide to do something like this. So visible face. So you have to do if a serialize hardware not equals null, then this. Otherwise, call return. Then fall back to something else. Or you can override this here. And do something else here. For instance, here you could, I don't know, call the default serialization function or call something else, do more logic there. And then basically move all the logic that you have in the wrapper here, move it inside the default implementation so that any code that calls this function here doesn't have to second guess whether or not the function will be actually, the virtual function will be actually called, or we're gonna silently fall back to something else. So it's, as I said, it's best practice. From the outside, of course, GObject cannot mandate any of this like functionality. We cannot literally tell you you can only do this, because the entire thing is predicated on custom code and virtual function pointers and whatever. So we can only rely on the fact that this is going to be a set of best practices. And if they are best practices, then you are kindly encouraged to follow them, but we cannot we cannot mandate you follow them. Right. And yeah, this basically kind of closes the book on interfaces. There's not much else here. You have the option in any complex code base, you will have a tension between concrete classes, final classes, abstract types, and also interfaces. And in general, the interface type provides you with a lot of flexibility because you can add new interfaces and you can expand them without breaking API. As I said, also the fact that interfaces are composed at runtime means that an object that in version 1 did not implement an interface can implement an interface in version 2 without breaking anything. Whereas you cannot take an object that inherits from type A and inject type B in the middle, because the size will change, the inheritance chain will change. So interfaces are fairly flexible and they'll allow you to expand your functionality in a safe manner, as long as you always provide fallbacks and you don't use properties. Or if you use properties, do not ever add new properties after the fact. On the other hand, abstract types are very useful because they provide you with a default implementation that is very much tied to state. Interfaces can also have some state, which makes them kind of like mixins, but not quite, but almost. So yeah, let's show how to hack around the fact that interfaces can actually have state. The trick is the fact that an interface can have a required type, and this required type can be anything, of course. But in this case, for instance, is G-type object, which means that when you're inside here, when you're inside the default implementation of the interface, this object here is going to be a concrete instance. It's not going to be an opaque type that nobody knows what it does. It's going to be, at the very least, for instance, a G-type object. So technically speaking, a G-type object, a GObject, is capable of storing data associated with its instance using the object set data. Using the GObject set data function and its dual GObject get data. Here. This is very low level. This is not recommended, though sometimes it will be the only option. Basically, every GObject instance is actually a keyed dictionary, which means that you can associate anything that fits into a pointer into a GObject using a string as an identifier. So it behaves like an hash table. So, but yeah, it's a keyed dictionary. This is very low level and it's not recommended because it's kind of slow. It imposes a bunch of conditions on the object itself when it gets instructed, so it adds some locking here and there. It's kind of not great from a performance perspective, so don't ever do this if you're creating like a bajillion instances. But it's useful, right? So it can be a useful thing to do, especially if you have some default behavior and you know how to handle all of this stuff. But in reality, it's not, strictly speaking, limited to GObjects. So if I have an example type, some state, and I require an example state object here, and I require it to be a prerequisite for this interface, it means that I can do something like this. And then I can do, I don't know, example state store key. Or if example state has key, return true. So at this point, even inside a generic code that doesn't know anything about anything inside the implementation, you can actually access the state because you're given a concrete instantiated type. So it's not entirely true that interface is completely opaque or it's completely like abstract and doesn't have any state, because you can change the default prerequisite to be an object type that can contain state, and you can call the API that deals with that state. You cannot contain state that is private to the interface, of course, because an interface has no instance type. But you have access to GObject. At that point, GObject can be used as a keyed store. So you can store state that nothing else knows about, and you can access it from your own implementation. Again, don't go crazy with that knowledge. Don't get drunk on the power of storing state from an interface that nobody knows about it, because it comes at a price. But it's possible. And it's possible to do this. It's possible to access a bunch of stuff. So it's not a case of being completely stateless. You do have the ability to set a default implementation, and that default implementation can do whatever the hell it wants. Even rely on the fact that you have a different you have a prerequisite that can store state. So it's not necessarily completely stateless, completely free of the capacity to store and recall information that is tied to the interface itself. But yeah, that's basically all there is to know about interfaces. Interfaces are just that, are abstract types that cannot be instantiated, that are tied to a type at runtime, not at compile time, and they are composed when the type is instantiated first. And they are flexible enough to be ABI compatible, forward ABI compatible, so you can add new stuff to an interface without breaking existing code, as long as that new stuff is not a property. If it's a signal, if it's a new virtual function, that's fine. Interfaces can have a default implementation, and that default implementation can also, under certain preconditions, can also store state and retrieve state and act upon it. Interfaces also have a prerequisite type, which allows us to ensure that any type that implements the interface also responds to a specific protocol or a specific API, which can also be used by the interface default implementation. And a type system will try to juggle most of this stuff for you. So you won't have to deal a lot with this. You just have to, if you're defining an interface, you can use this gdefine interface macro. You also have, so you don't have to deal with this CRUD here. You also have a gdeclare interface here. Let me double check. Here. It's going to be example, serializer, and then the object. Yep. You can use the macro gdeclare interface, which will not use iface as the suffix, but it will do. Will use serializable interface. Use the interface suffix for you. So you will have to do something like this. You can always figure out whether or not the code has been written by an old hand or somebody that has learned GObject a while ago, before the gdeclare macros were a thing, because their interfaces will usually be called iface instead of interface, because iFace is shorter. So there is a good way to determine the age of the author, or at the very least, if not the actual age, the time when they started hacking on GObject related code. But yeah, this is all there is to know on interfaces. There are, as I was saying, the previous stream on last Wednesday, there are a couple of caveats there that tend to trip people. The fact that interfaces are forward compatible is something that is not automatically is not automatically graspable by the people that start using them, because people are used to the class structure being ABI fixed. So this is kind of a good thing to raise, but also the fact that properties are problematic. So it's another thing that people don't immediately grasp on that. But other than that, interfaces are not very complicated. The entire type system is not very complicated. If you know enough object orientation, like if you understand the basics of OOP, then the GObject type system is not very complicated. And object-oriented programming is kind of a classic these days in everyone that teaches computer science or software engineering. So the chances are that most people are familiar with, at the very least, the basic concepts. And as I said at the very beginning, GObject is kind of a demon child between C++ type system pre C++ 11 and the Java type system, early Java type system, so 1996 to 1998, 1999, which means that the basic concepts are kind of old. They are not new stuff at all. Even in the relative age of computer science, they are not old concepts. They are not new concepts. They are fairly old. So it should be pretty easy to grasp how the entire thing is working. Less so how it's put together, but for that you want to ask somebody that has been shoving their hands inside the guts of the type system, which means that you probably are going to be asking, I don't know, probably 5 people on this planet. Maybe 10 if we're lucky. But yeah. Okay, so it's been an hour and a half. I think it's time for a little bit of a break, so I can refresh my tea or do something stronger. And then we can switch to an application of some of the concepts that we've been looking at in this long deep dive. Not particularly interfaces, because MVCs don't really use interfaces. But we are going to look at how to implement a model view controller pattern in GObject and GTK, and basically how to structure your application code so that it takes full advantage of things like signal emission, property notification, and the ability to bridge things together loosely instead of shoving all the logic inside the GTK widget that is going to display it and interact with the user. So yeah, stick around. I'll be back in 5 minutes, and then we can go and write some code. So we're back. Made me some more tea. So I hope I didn't basically just burn everybody's brain at this point. It's I can see that sometimes this stuff is complicated, or it can be weird to explain all of this stuff, especially if you already know a lot of this, but or at the very least if you understood the same concepts that apply to other languages. The thing that makes GObject interesting is not the bleeding edge theoretical framework, because it's really not. But it's the ability to map the most of the concepts here to other languages, to existing languages like C++, JavaScript, Python, Perl, Rust, whatever. Sometimes those languages have to contort themselves a little bit to make them work, to make this concept work and apply. But in general, you can understand most of this stuff, and you can reuse most of this stuff in different languages. The properties, the fact that properties notify of changes, the inheritance, the fact that you have interfaces as well as types. So you can take the theoretical framework and then apply it to other languages as well, as long as you're using libraries that are based on GObject. And I guess that is the reason why GObject has this kind of staying power in the free software community, or in general the GNOME platform. The fact that you can write your application in multiple languages or using non-C languages, like C and C++, but you can also write your application in Python, for instance. And the fact that you can write your application in Python reusing the same mechanisms that are also available in C or Vala or Perl or whatever have you. So yeah, I guess that is the reason why GObject has been, I'm not gonna say so successful, because GObject occupies a very tiny niche of the software market, but the reason why it has been working for the past 20 years, the reason why it hasn't been completely replaced by something like 2 years in, and not just because it sits at the core of everything we do, but mostly because it's flexible enough to allow you to do things that are not trivial. It allows you to create big monsters of API, like an entire graphical toolkit, but also things like libsoup, which is an HTTP library, or write an like simple serialization and deserialization formats like JSON-glib, but also GStreamer that deals with an entire spectrum of media, from audio to video. So GObject is kind of good, actually. It can be better. It definitely has some problems. Performance is one, like multi-threading is very costly, and there are things that are just damn awful. like the properties. But it works. If it didn't work, it wouldn't be around still. It's not like we enjoy writing like a ton of C code. It's just that it it's it works. So I don't know. I guess uh, good enough is good enough. Sometimes good enough is good enough. It's empty. Really warm tea. Okay. Really hot. So I did kind of speed through the entire thing, but and to be honest, I hope people have questions that I can answer. Because I don't think for even a second I am so clear that nobody has problems with what I've said and understood everything. But yeah, if you have questions, you can leave them in chat, or if you're watching this on the VOD, then feel free to leave a question in a comment it down below. It's absolutely fine. I tend to try and answer all the comments there, even though the ones that I have no idea what why they should be related to the video itself. But yeah, again, I'm happy to try and answer questions. There's also Discourse, the Discourse instance for GNOME, which is discourse.gnome.org. You can leave questions there as well. I read all the topics, and I'm not kidding. I read them all because I'm one of the admins and I'm one of the moderators, so I have to read everything. Well, that is not true. I get flagged. Stuff that I have to moderate gets flagged, so I can't actually wait. But yeah, again, if you have questions, just feel free to ask them. But yeah. So that'll be up tea. Yeah, speaking for an hour and a half, like straight through, it's doing wonders for my throat. Right. So as I was saying, let's do some actual coding here. And let's try and do MVC pattern. So for the few like people that were frozen in time in 1953 and have been thawed recently, a model view controller pattern is a very simple pattern that is based on the assumption that you have an object that stores the state, which is the model or state object. Then you have a view, which is the representation of the data inside the model. That data can be transformed by the view in a way that is relevant to the interest of the people viewing the data. But it can also be straight, like a straight port. And then you have the controller, which typically sits in between and sometimes can be entirely elided, like removed from the picture, because it's not always necessary. But the controller is basically something that operates on the model on behalf of other elements that are mostly tied to the view. So the model itself is not manipulated by the view, but it's manipulated by the controller, and the controller also handles things like state serialization and the ability to save and restore state on the model. Sometimes it's part of the model. It's a fairly flexible like pattern. Again, sometimes the model and the controller are the same object. Sometimes the view and the controller are the same object. Sometimes there is no controller at all because the view is only a read-only view. So there is no need to control the contents of the model. The model just presents the information. So you can change the vertices of the triangle in the model view controller kind of at will, depending on the particular scenario you're in. So let's start with a simple template using GNOME Builder. So this is the default template for GNOME Builder and GTK and GNOME 4. GTK 4 plus libadwaita, so the GNOME template. Doesn't do anything, it's perfectly fine, even though right now this example application is actually using the MVC pattern in some places. For instance, the obvious way is the menu. The menu is defined as an XML description of the elements here. The elements here are transformed into an object called a GMenu model, which contains the name of the menu item and the action that will be invoked when the menu is activated. And then you have the widget here, which is a menu button that has a popover widget around here that takes the menu model and creates the widgets that represent the menu item name and action. And every time you activate one of those widgets, an action gets activated and some other code gets invoked. So GTK is already using the model view controller pattern internally for a lot of its types and a lot of its functionality. But we want to add our own stuff. So we're going to start with the very simplest thing we can think of, because I am devoid of any sort of spark of ingenuity. So we're going to create our model, and the model is going to be a very simple counter. So we start with the header file, and then we declare final type with sample counter. It's going to be a GObject, and then we need to include here we begin vehicle. So as I was saying, this basic counter object, so it doesn't have any public API except the type itself. Let's create the implementation. So counter model. So we include concept.h, then we include model, it's a final type, so we need to define the structure for the instance type, the instance. And since it's counter, we are going to have a counter field there. Then we are going to do G define final type. And it's a GObject. And then the example counter init. Okay, so this is our skeleton type. It's very simple. Let's add the object here. Models. There you go. So it's a very basic skeleton of a GObject. We define here the fact that the type is a final type, which means that the class structure is in the public header. It's available inside the, well, it's going to be in the expansion of this macro here. And then the instance structure instead is going to be private to our source file. We use gdefine final type to generate all the GObject, well, the get type function, the fact that there is a class in it that's going to be called, and there's an instance in it that's going to be called. The example counter has a field, which is an unsigned integer that is counter. Whenever we create a new instance here, it's going to be a 0 field. So we actually maybe want to add a constructor here. So counter example counter new. And here we are gonna need the counter. And the only public API is going to be the constructor. And that's it. Let's try and build it. Oh yeah, there's no config.h, of course, because we are not using that. All that it's die hard. Right. As I was saying, this doesn't do anything because the skeleton, it's perfectly fine. So the first thing you do, it's our model object. A model object has only one thing to do: contain the state, so contain all the information that has to be represented elsewhere or modified by other classes, and then notify that the state has changed whenever that happens. And in order to do that, we are going to use a property. So counter this one, and then we're going to use spec props. So we are going to need a property that is both readable and writable. So let's already declare, well, define the skeleton for set property. And we're also going to do this for our get property here. And here we are going to assign those functions to the GObject class structure. Oh, what is it doing? Yeah. Yeah, that's fine. And now we have to define the property itself. So counter props. It's going to be prop counter equals spec event counter null null. It's going to be between 0 and g max event. Default value of 0. Read write. Static strings. And then the implementation. Set property is going to be self counter equals value get event. And this one is going to be g value set event. And that's it. Since the instance will be 0 field at construction time, we don't need to do anything here. So to avoid unused argument, unused parameter warning, we passed g new C unused, which is expands to a compiler attribute that is valid on GCC like compilers like GCC, obviously, and CLang. It basically says if this argument isn't used, don't warn. It's perfectly fine. So this is a very basic object that stores a value and then returns a value. And every time the value changes, like the counter property changes here, the end result is that there will be a notification emitted by GObject itself using the GObject notify signal. Very basic, like low-level stuff. It's nothing complicated. As you can see, I didn't had the specific API to like set the counter and get counter because it's not entirely needed. We'll see what happens whenever we use the controller after that, but for the time being, it's perfectly fine. So this object is not really a counter, is just a state object that controls the counter property here. The stores and retrieves the property, or stores and retrieves the count. In order to manipulate the counter, we are going to need a controller. So let's create a new file, call it counter controller. So we are going to include the object, and then we are going to include counter model here. We're going to define our type. This one is another final type. And we are going to give it a constructor as well. But in this case, it will take the counter as the model. Yep. We're also going to create a new file here. Counter, Control C. We're going to include that. It's a final type, so it's an object type. Controller. Yeah. And then we have example controller. Yeah. So I'm already giving away the game, but the controller has a model attached to it. So, and the model is part of the construction. So whenever you create a controller, you also have to have a counter model that you can pass to it, and you cannot change it anyway after that. So here, example counter model. No. Yes. Yes. So for this case, we not only want to have set and get property, of course. Here, default is the object when so let's copy this into our get property function. And we are going to use here GObject class. And GObject class. Yep. Other thing. Normally we want to have a set and get property because of course we do, but we also want to have a dispose function. Well, yeah, dispose function. Let's use that. Because we are creating an instance of an object, the example controller, and then taking the model object, the example counter, and associating it with it at runtime, at creation time, which means that now the controller should own a reference, should acquire a reference on the model, and when the controller goes away, it should relinquish that reference that it acquired. So in order to do that, we have to implement the dispose virtual function of GObject, which is part of the destruction sequence. Example controller. And we use GClearObject self model, and then we chain up to the parent class. We use GClearObject because A, it's short, it's a single it's a single function call. The other thing is it's null safe, so if self model is already null, it will be ignored. And this is important because dispose can be called multiple times. So strictly speaking, the object can be disposed multiple times, and if the because during so there can be an explicit disposal run, which means going through the dispose only even if the reference count is greater than 1. But there's also the possibility of auto vivification of the object. So the reference count of the object goes down to 0. The dispose sequence is run, and at some point somewhere along the line, somebody acquires a reference on the object again. At that point, the object gets placed in a suspended animation state or an inert state. The object is still alive, the object is still valid because it has to be. The memory is still allocated, you can still call API on it if at all sensible to do. But the dispose implementation has already run, which means that at some point somebody might drop the reference that the object still has. Dispose will run again, and in that case self model will be null, and GClearObject will not do anything. If you don't check for null, if you don't check for null and you don't nullify, you might end up releasing multiple references on an object, or like trying to release a reference on a garbage pointer. So always make sure that the dispose implementation that you provide is null safe and can deal with reentrancy and can deal with multiple invocations. So if you have a pointer, set it to null, check for null, do whatever you want, and then set it to null. If you have a signal handler, check if the signal handler is not 0, disconnect it, and then set the variable that holds the signal handler ID to 0. Same for source SID, anything else that comes to mind that can be in a null state, so 0 or null. So always make sure to double check there. But also, we want to do stuff when the property has been set. So first of all, we are going to set the property here with obprobs. We're going to define the property, sorry, not set the property. Model, it's gparam spec object model no. The type is a sample type counter. Is gparam read write gparam construct only gparam static strings. And then we install the property. Something I also forgot to do. Minus and props and then props. We also have to go to counter model here and call that function. And then we have to implement that function. So here we do self model equals g value dot object. What this does is if the value contains an object instance, return that instance with an acquire reference. Strictly speaking, if you want to be like a good denizen of the ecosystem, you also can do self model here. But it's not strictly necessary in this case because the property here is gonna only be set at construction time, and construction time means that the model variable here, the model field inside the instance structure, is going to be null, because it's going to be reset by the GObject construction code. And since the property is construct only, it means that it cannot be set at any other time. And the model has to be valid when we create the instance of the controller. You cannot create the controller and then set the model. So that is, strictly speaking, unnecessary, even though it's like good hygiene, good code hygiene to be careful with this stuff, especially if at some point you decide to change the code to allow setting that property at a later time. So clearing the object is gonna be fine. And then we are going to g value set object. The main problem now, and it's kind of obvious in retrospect, but it has to be said, is that any pointer type for a property can be null. It's not specified anywhere that the property must not be null. There is no validation performed at any point for that. So how do we know that GObject new was called with an actual model here? For instance, by this API here at the C level, or by a language binding that called GObject new directly. We have to do some validation there, and the validation can be performed by the constructed virtual function. So you do this, static void controller constructed. And here, then you do example controller self. And you do gassert is counter this is a very heavy mallet, but basically just assert that this is valid. This is the model is set and it's set to a valid instance, an instance that we actually can use. Let's see, in Meson build, we have a counter controller now. Yeah. Dum. And it's fine. So, we are not using anything here, so let's also use here gnuc unused. The other thing that we have to do inside the controller, though, is no, not here. Sorry, this will come later. The other thing that we have to do inside the controller, though, is providing an API to control the state object. So adding an API that allows you to increment and decrement the counter. So let me double check the thing. Right. So adding new API. Let's call it, for instance, void example controller increment. Okay. And example controller decrement counter. As you can see, we don't have any API that retrieves the counter value from the model. That is not what the controller is meant to be doing. It's only meant to be operating on the model. So this is going to be counter 0 get self model. Now we are asking the model for the value of the counter. We increment it by 1, and then we call GObject. And this function here, GObject set, will emit a notification if the counter has changed. The same thing will happen with the decrement. Except, of course, it has to be safe. So if the counter is greater than 0, And in theory, we could also check here if counter is less than G max equivalent. The validation could also be performed by the model itself, and it will in part be done by the model itself. If you try to pass a negative value for the counter here, you will get a warning. If you try to pass something that is larger than G max uint, you will get a warning there as well. Some validation actually happens, but it's better to have it here inside the controller, which is the thing that manipulates the state. Let's try and build it. Build succeeded. Okay. So right now, the code doesn't do much. Well, the code doesn't do much to begin with. It's not a huge, like, we wrapped a single unsigned integer with two objects that are going to weigh in for a lot more than a simple unsigned integer. But the same pattern applies to any property. So it's not just unsigned integers, it's more complex objects, for instance. It's going to be strings, it's going to be any other complex type that can be represented by a G type and can be represented by a property inside GObject. But right now, yeah, the code doesn't do much. It's a state object that contains the counter, the unsigned integer value, and then a controller that it can increment and decrement that value. The important thing is that controller does not observe the value itself. The only thing that it does is retrieve the current state and increment it or decrement it. So it doesn't do anything else with it, because the only thing that will represent that information, that will present the information to the user, is going to be the view, and the view can be arbitrarily complex. And in our case, we are going to have a complex widget that's going to be a little bit more than just something that presents a number to the user. But for the time being, we are going to use something like this. So counter view UI. Oh, that's nice. I did not expect that. So let's try and restart. So it's going to be a template here. So we are going to be creating our little template. It's going to be a GTK widget, and it's going to be called counter view. Interface. It's going to have a child, and that child is going to be an object class GTK box. Property name is going to orientation. It's going to be a vertical box. It's going to be 12 pixels of spacing. And the first child is going to be another box. This time is going to be an horizontal box, so it doesn't need an orientation property because the default orientation value is horizontal. It's going to be less spacing. And it will have another child. And the first child is going to be class GTK label. Okay, property name x line is going to be 0. And the other child object is going to be entry. No, that's just another label. Not going to have anything. It's going to be aligned as well. Okay, so this is going to be a very simple display here. It's going to have a vertical box which contains another box which contains two labels, one near each other in an horizontal layout. We are going to use an extra box here because in the future we're going to add more stuff, but this will come later. So this is the template here. This one got deleted. There you go. But we are going to need a counter view h. It's a GTK widget, of course. So we're also going to include counter model, counter controller, fine, sample, type, control view. We are going to have to modify this to have some counter view, otherwise the type won't match. Okay. Final type. And it's a widget. We don't bother with a constructor because we don't really care. We are going to deal with that later on, but it doesn't matter at the moment. So here. The GTK widget. And it has an example controller here and an example model. The controller for now is not going to be used, so I'm just putting it there for future use. So it's going to be controller model. Okay. And then we are going to have our solid counter view class in it. Yeah, this is going to be used in the future. For the time being, we are going to create the model ourselves. So it's going to be example counter view, and the controller is going to be example controller new. Actually, yeah, we can just remove this here. It's fine. And this is going to be example counter view expose. Here, clear controller here, and we clear object the model here. And then we chain up. This is also a template, a GTK widget template, which means that we are going to have to init the template here. And we'll have to do the widget class dance. So, first of all, we have to add the counter view UI to the gResource file. Counter view UI here. Then we'll have to do exactly the same thing that. There we go. There we go. And then since this here we have a widget with a child here and has a single child, we are going to use GTK widget class set layout manager type. We are going to use a bin layout so that the entire thing gets treated like a bin widget. A bin widget, it's a widget that allocates all the space to it's theoretically it's single child. In reality, GTK bin layout allows you to have as many widgets as you want, and many child widgets as you want, and it will use the alignment and expansion flags to control the size. In this case, we should probably do something like property name h expand name h expand. And this one is going to be H line center, and V line is fine. Okay, so here we need to add the counter view.c file, and let's try and build it. And yep. What are you doing? Oh yeah, here is now model, of course, it's counter. And counter view should be included. Counter controller here and counter model here. Okay. Yep. Yeah, forgot a cast. South. Okay. So let's build it. Everything seems to be working fine, but of course, if we run it, nothing happens because there's nothing there. So let's modify the window UI. So instead of having a GTK label here, the class here is going to be example counter view. Let's call it view. And it doesn't have anything there. Yeah. This is a side effect of the fact that we're creating our own type here. So we have to go inside the example window here and do gtype ensure example type counter view and include here interview.h. And you can see here. Yeah, it's fine. So here you can see right now it's very poorly aligned, so we'll have to align it ourselves after that. But as you can see, now we have our widget, which has a counter and doesn't have anything there. And of course, we have to deal with the fact that there's an additional box there, and it's fine. So let's also here this. We have a view here, and instead of a label, counter view. The gtype ensure here is necessary because the type that we are using here is not registered at the time. So we have to basically tell the type system, hey, whenever you see a type called example counter view, it is mapped to a type that is the example counter view type. But in order to do that, we need to basically tell GTK Builder that there is that type. There are a couple of ways to do that. One is to literally provide the type function to be called whenever we try to instantiate this type, which is not really super nice. Also, it's very C only. The other option is to use the gtype ensure function that basically calls the type, the get type function that you're passing to it, and discards the return value. The act of calling that function and discarding the value ensures that the type is registered, even if nothing else is. let's also center this. It's very useful if you are constructing your custom types and you have a custom type that also constructs children that are custom types. In this case, we have our example window here, which is a custom type, and an example counter view inside it, which is another custom type, which means we have to tell the type system, hey, this type here needs to be available before we instantiate the template for this type here. The other thing we have to do here is that we need to unparent the box here. It's another, this is here. There we go. Here. So the fact that we are inside, we are creating a custom type that has a custom widget that has children inside it. We have to take ownership of that, of those widgets. It's going to be G clear pointer self main box GTK widget unparent. There you go. And then we have to do GTK widget class add, no, it's not add, it's let's copy it, bind template child. Widget class example counter view main box. Okay, run it, and there you go. So yeah, here we have a counter. The counter doesn't do anything because it doesn't have any data whatsoever inside it. So how do we take the view, which is our widget, which is our label here, and we modify it so that it represents the current value of the counter? So first of all, we have to give it a name, and we use view label here, and we bind it as well. So it's going to be widget view label here, and we are going to add another binding here. There we go. And then we have a model here that we can represent. So in order to represent the model inside the view, we are using properties, because of course we are, and we are using property bindings. So object bind property, this is going to be not a plain bind property, but it's going to be bind property full. But we'll see what happens there. Self view label binding. So we want to bind the counter property of the model to the view label property using a default binding, which means that whenever the counter property of the model changes, the label property of the view label changes. It's not a bidirectional connection, so the view will not influence the model at all. at very least the view label will not influence the model at all. But of course, this will not actually work. So we can save it here. And it doesn't work because, let's actually, we need to do this. Finding sync create. The sync create flag, additionally, so we run it and it doesn't update anything because the counter hasn't been updated. It's still 0 internally. So we want to reflect that 0 at the very beginning of our application. So we use the sync create. Sync create is just a flag that says, please fake a notification so that the current value of the model gets applied to the view as if there were an actual change. And we'll see a warning there. No. Oh yeah, because there's an automatic transition, yeah. So it's not strictly necessary. I always forget that. But basically, internally, the type system will transform an unsigned integer value into a string because it can do that. It cannot do the opposite. So if there is a string, it will not be able to take a number and turn it into a string. Sorry, if the property here were to be a string and the view represented a number, you would get a warning saying, hey, I cannot transform a string into a number, but I can transform a number into a string. So you don't have to do anything else. But yeah, now we have a binding between the model and the label. So every time the model will change, the label will be affected and will update its contents into that. So the view is already hooked up to the model. Now we have to have a way for the view to modify the model through the controller. So if we want to actually see what happens when you do that, let's do something like this. Timeout add seconds. So every second we call increment on time, and then we pass self here. And then we have a static Boolean increment on time data example counter view then we do example controller increment counter of controller. GBoolean. Jesus. Yeah. So every second we increment the counter using the controller, and the counter increments the controller modifies the model, and the model notifies the view that there has been a change. It's very simple. This is automatic. We are going to look at a way to make it user-driven instead of just automating stuff. So in order to do that, we are going to go into the view and add a separate child. which is going to be another GTK box. And another. It's gonna be another horizontal box. H line center. It's going to have two children. The first one is going to be a GTK button. It's going to be ink button. The label is going to be a big plus. And the other object is going to be a similar one. It's going to be called deck button, and I have a label that is going to be called minus. Go back here. We bind and we're going to add two more widgets here. There we go. And then we are going to do signal connect self ink button click. And the signal connect. And we're going to need two callbacks. And it's going to be sample controller increment counter self controller, and same thing but for the decrement. Okay. There we go. And then here and here. And there you go. Keep adding. And keep removing. So what did we do? We are handling the clicked signal on the increment and decrement buttons, and those will call the counter increment and decrement methods on the controller. The controller will then do that, will then change the counter stored inside the model. The model will notify the property change, which will then be reflected by the label through the property binding. And this is how you do model view controller splits with GTK and GObject. Of course, this is a ton of code for a simple counter. there are lots of ways to simplify all of this. You don't need all of this split and stuff like that. But this is how you do it so that it's flexible enough to be modified in the future, to be expanded further on. You can also, so this is the GObject bind property that transforms automatically unsigned integer into text for the label to display. But you could use GObject bind property full to pass a custom transformation function that will take the value from the model and set it as a value on the view and apply any transformation you'd like. You want to transform this into another value. For instance, you want to append or prepend something to the numerical value, you can do it. You can transform this into like a mapping function. The model is an incremental unsigned integer. You want the text to like increase by a power of 10, you can do it. It's incredibly flexible, and it separates the areas of, well, the context. It separates the area of influence of each part of the UI. So you have business logic clearly separated into the controller object. You have state tracking clearly separated inside the model object, and you have a view that is clearly separated inside its own widget tree. And of course, you can have multiple views of the same objects and operating on the same controller as well. So even though this might look a lot of code to do something incredibly simple, it's also the beginning of what you can do with this kind of pattern and what you can do out of the box with GObject. Because yeah, the widget tree is part of GTK, of course, but everything else, the controller and the model, is all pure GObject. It doesn't have any additional library or dependency. This is what you can achieve with GObject out of the box. Other languages have frameworks for this. There are frameworks that all they do is this, and you get this for free out of the box with GObject, which is incredibly powerful, incredibly important, because it allows you to build your application as a set of composable elements. You don't need to have weird like, you don't have to inherit from complex data objects or whatever else you have it. You can literally just inherit from a GObject and you're done. It's already done for you. And on top of that, GObject has, well, GIO, but GObject still has the ability to track multiple models. So if I wanted to have, I don't know, a million counters, a million different counters, I could do it with glist model. And glist model stores objects, and whenever you add or remove an object, it will notify anything that is using it that the content, not the contents, but the list has changed. And with GTK4, you have GTK list view. So if you have, if you want to display a million counters in a list, you can do it, and all of them can connect to the controller and sorry, every row can connect to the controller and can connect to the view of the model to present that information in a way that is perfectly natural to describe, instead of being a hodgepodge of business logic and widgetry inside the same class. So I guess this is the important part of the of this deep dive is GObject out of the box provides you with the tools to create very flexible applications and does not require you to have additional functionality imported through libraries or extensions. It's already there for you to use it. And you can create very complex applications that have complex views on complex data. And it doesn't require you to do anything more complicated than just a bunch of property notifications and signals to modify an existing object, an existing state tracking object. And again, GTK and GIO already use a lot of this stuff under the hood. You have the settings API in GIO. Settings API is literally a model which is described by the settings schema, and you get notified of changes that happen on the settings storage for you. GTK has model view controllers all over the place. Menu models, popovers, the list view, and the column view for the new scalable lists and trees. So it is a good idea to structure your applications, basically any application code, around this pattern, because this pattern is so pervasively used inside the toolkit and inside the platform that there is no reason not to adopt it for your own code. And it gives you flexibility, it gives you power to do what you want to achieve and still maintain the code a lot more simply than you would do if you just threw everything together. So, right, so I'll take this code here and will very likely take like clean it up a little bit, comment it in a way that is reasonable to understand just by reading the code, and then put it inside a Git repository that I will then link from the video description of this deep dive. Hopefully I didn't lose all of you behind this. I mean, as I said, it's not incredibly complicated, and you can take the VOD and then just go over it multiple times. And as I said, alongside with the code, should be easier to follow through. But the concepts behind it, behind this entire effort and this entire deep dive, are universal to how GTK applications are put together. And to a point, this pattern helps you with the fundamental question that you will be faced with whenever you start a new project, which is, how do I structure my project? How do I structure my application? You take the application idea and you extract the fundamental data type that you are going to interact with, that you're going to present to the user, that you're going to manipulate. For a media player, the song and the playlists are two basic data types. For a weather application, is going to be the location and the current weather at that location. For a clock or a word clock, is going to be, again, the location and the time. And once you have that information, that once you have a data type that describes what you're trying to present to the user, then you create a view around it. So the widgetry that will be in charge of presenting that information to the user. And if the user is supposed to be able to manipulate that information, then you will also create a controller type that will modify the model that contains the state of that information. And if you separate the domains well enough and strongly enough, then you will be able to scale your application in the future to multiple views and multiple controllers. You will be able to do things like swap models on the fly, swap controllers on the fly, swap views on the fly. You will be able to use multiple views to display the same data. So I guess this is the core tenet, the core design principle that I want you to take away from this, which is once you understand how to represent the data that is at the core of your application, and once you understand how you want to present it and modify it, then you can build your application around this pattern. And it's going to get easier and easier the more you do it, and the more you model, no pun intended, your application around it. So I honestly hope it was useful for everyone who's still here, and also everyone who's watching this on YouTube. And I do also hope to have in the future some more time to deal with the other deep dives inside GObject. As I was saying at the beginning of the stream, I want to be able to do a dive on box types and instance types, so that people understand when to use a box type and when to use a GObject, what are the trade-offs and what are the benefits of each approach. But from a basic perspective, I think this deep dive should have already helped people that are unfamiliar with the GObject API and the GObject type system, and GTK as well, to a point, to understand how to properly use this platform and this toolkit. And I don't know, maybe in the future we'll do more. And if people have questions, if people have areas that they are unsure about, then I'm happy to do streams about it, and happy to do more deep dives on specific parts of the platform. The GObject platform, the GNOME platform, as it is, it's not like massive, doesn't span it spans a few libraries, and it spans various domains, but we try to keep it consistent between libraries. So the patterns, the API patterns, the behavioral patterns, they are kind of similar. So it should be possible to take what you learn in this deep dive or in the documentation of other libraries, and then apply it to other libraries and other APIs. So hopefully it will be useful for somebody at this point. And it only took 3 hours and 15 minutes. So I'm a little bit earlier than I expected, to be honest. I thought the part on the live coding would have been a little bit longer than this, because I am not the fastest coder in the West. But yeah, I guess it's time for the usual YouTube outro, which also will probably serve as the introduction to this series, whenever I am able to take it and edit it into human digestible video that is not 9 hours long. So let's try it. Have you ever wondered how GObject works? And have you ever wondered how GTK uses it and how to use GTK to make your applications and to start your applications for the GNOME platform? I'm going to explain how to do this in this deep dive for GObject, going through how GObject works, how objects are instantiated, how they are destroyed, how properties work, and how signals work. And on top of that, I will try to explain how to take all the functionality of GObject, properties, signals, and everything else, and then create a model view pattern implementation so that you can structure your applications around it. Okay, so hopefully it will be usable and I will not have to take another do another take of it. So yeah, thank you very much for everyone who's still here and is I hope that you learned something new or I didn't bore you to death. Oh yeah, the outro at this point. So yeah, if you want to know how the GNOME platform works and you want to see me struggle writing C code and Rust code and Python code or writing documentation for the GNOME platform, then why not subscribe to my YouTube channel? Otherwise, if you want to see me do this live on Twitch, you can just follow me there, twitch.tv/Avassi, where you will get a notification every time I go online, which is usually on Monday, Wednesday, and Friday at 4 p.m. London time. For everyone else still here, thank you very much for following along. And I hope you will have a great rest of your Monday and a great rest of the week. And I shall endeavor to see you all on Wednesday or Friday, depending on time, hopefully, and on bandwidth. I still had some problems today with my streaming because, yeah, BT sucks. That's sadly the truth. I hope it didn't suck too much. Oh, thank you, Georges. And yeah, have a great rest of the day and great evening if you're in Europe. Great rest of your afternoon in the US. And I shall see you all next time. Bye.